Hi, so in this video, I'm going to explain assembly language in the topic of data transfers, addressing, and arithmetic, and also in the topic of conditional processing. So for the program in the Microsoft Visual Studio, we have three options: Chapter 4, Chapter 6, and exit from the program. So we're going to choose Chapter 4. There are several subchapters in Chapter 4. We're going to choose the first subchapter, which is data transfer instruction. So data transfer instruction. In data transfer instruction, there are move instruction with direct memory operand, move ZX instruction, move SX instruction, and also exchange instruction, and direct offset operand. Move instruction with direct memory operand. Here is the example. Num4 is the direct memory operand that I have defined here in the data. We move ZX. Here is the example. We're going to move a binary number into AL and use the instruction of move ZX. So for the move SX instruction, move a binary number into AL and use the instruction move SX AX AL, and we will get the result like this. So for the exchange instruction, we're going to change the value of two memory, which is val3 and val4 that I have defined in the data. So here we can see that the value of val3 have been changed into 7, which I initially defined it as 2, but it is now 7, the value of the val3. Direct offset operand, I have defined array 1 here, and this is the example of the direct offset operand. So for the move AL array 1, we'll get AL 15, move AL array 1 plus 1, we'll get 30, and move AL array 1 plus 2, we'll get 45, which I have declared here. So for the second subchapter of Chapter 4, addition and subtraction. In addition and subtraction, we have increment, decrement, add, and sub instruction. First, move num4, which I have declared as 5h to AL. We're going to move num4 to AL, and then increment AL. So increment AL will get 6. Decrement AL 2 times. Decrement AL 2 times will get 4. And then add 5 to AL, which now AL is 4. So add num4, which is the value is 5, into AL, and we will get 9, the value of 9, and subtract AL by 3, sub AL 3, we will get 6, the value of 6. So for the negate instruction, we actually have to declare num5 by -4 in the data and move the num5 into AL and then negate AL, and the result should be +4 because it will change the sign of the value. So for the arithmetic expression, the expression stated here is val1 equal to val2 minus with val3 plus val4. For the third subchapter, which is the data related operators and directives, so for the PTR operator, this is the example. PTR will, even though the array that we declared is in byte, but with PTR we can move this array into AX, which is for the word register. So for the type operator will return size of an element in byte. This is the example of the type operator. which will result in 1 because the val2 that has been declared on .data is byte and the size is 1. Length of operator, it will count the number of elements in the data declaration. So in array 1 I have declared 4 elements, which is 15, 30, 45 and 60, and it should be resulting in 4. So for the size of operator, it will multiple type by length of. So the length of the array is 4 and type of the array is 1. So 1 times 4 is 4. So the size of for the array is 4, and that's it. For the indirect addressing, we have indirect operands. Indirect operands, array sum, and this is the example that we use using the array 1 that has been declared. Also for the array sum, we use the array 1. So for the last subchapter of chapter 4, which is the JMP and loop instructions. So we have jump instruction. JMP instruction is an unconditional jump to a level, which the syntax is jump JMP target. For example, we can see many examples in the program, such as here we have jump chapter 4, which after the procedure has ended, it will jump back to the chapter 4 procedure. For the loop instruction, here is the coding example for the loop instruction. So move AX with 3 and move EAX with 8, and then increment AX, and that which means we will adding the AX value 8 times. So 3 plus 8 is 11. So we get here the result of 11, which is the result of the loop. And that is all for the chapter 4. Back to the main menu, press 6 for the main menu, and we're going to go for the chapter 6. So chapter 6, here I include 3 subchapters in chapter 6, which is Boolean and comparison instructions, conditional jumps and conditional structure. So for the first Boolean and comparison instructions, Boolean and comparison instruction have AND or XOR and NOT instruction. Here is the example. So first, move a binary number into AL. So and do the AND instruction on the AL with a binary number, and this is the result of AND instruction. So for the OR instruction, the result of this result will be OR instruction with this number, and the result will be here. This is the result of OR, and this result will be XOR with this number, and it will result in this number at 11001010. And if we do the NOT instruction on this number, we will get the result is 00110101. So for the test instruction, it will perform non-destructive AND operation. So test instruction is here. For the CMP instruction, it will compare destination operand to the source operand, and it will perform non-destructive subtraction. So for the CMP instruction, this is the example of the CMP instruction, and it has been used many times in the program. Here we use CMP. So for the second chapter, which is the conditional jump. Conditional jump have 3 types. which is for type, which is based on the specific flags, based on equality, based on unsigned comparison, and based on signed comparison. So for the specific flag, one of the example is JZ, which is jump if zero flag is set. For the equality, based on equality, which is the JE, which is jump if equal, and it has been used many times in the program here, in the option here. So for the unsigned comparison, JA, the example is JA, which means the jump if above. So for the example, the value of val 4 that has been declared in the dot data is 7, so 13 is larger than 7, and because of 13 is larger than 7, it will jump to the L2 here, which will return the statement here. The statement, it will return this statement, which 13h is more than value 4, which is the 7h. So for the sign comparison, the example is JG, which is jump if greater. So for the example here, for the third subchapter of chapter 6, which is the conditional structures. So for the block structured if statements, so for the statement is if val 2 is less than or equal than val 3. So if the statement is correct, 7 will be moved into X, and if not, 5 will be moved into X. So here is the example. So the output is statement is false, which means the statement is false and it jumped to here. So and for the compound expressions with n, it will short circuit evaluation. First expression is false, second expression is skip. So if the statement, if val 3 is less than val 2 and val 2 is more than val 4, whichever statement is false, it will turn out as false because this is an expression. So from the result we can know that both the expressions are true. So for the compound expressions with or, the statement is if val 4 is larger than val 2 or val 3 is less than val 2. It has been resulted in the statement of one of the statement is true. So that is all for the chapter 6. Back to the main menu, and we have reviewed both of the chapters, so we can exit the program now.